Thank you for the introduction. All right. Hi, everybody. Thank you so much for attending this session. It's truly an honor to be here at Spark Summit in front of all of you. And today, I'm going to talk about the way we're utilizing Spark within business analytics at Edmunds.com. So about me, my name is Blagoy Kaloferov, and I'm a software engineer within the data warehouse team at Edmunds.com. And back in 2014, I was given the task of fostering Spark and Spark SQL adoption within business analytics. And that has been a great and insightful process. And what about my company? Well, Edmunds.com is a car buying platform. And we do have a solid user base of more than 18 million unique visitors each month. And essentially, we are providing rich editorial content, vehicle information, and inventory items to our consumers so that they can find the best car for their needs. So in addition to that, we have to deal with the latter aggregates and tons of other data sets that allows us to internally make the necessary decisions to optimize the user experience of our consumers on the Edmunds.com website. And today, I'm going to tell you how Spark plays a part in that role, in that process. So the agenda for today includes the following. I'm going to give you an introduction to our architecture with and without Spark, and also give you our proposition. Then I'm going to go over how we made the most of our data through Spark SQL. And finally, I'm going to talk about a project that has to do with the way we compute ad revenue on our website, and that was only made possible thanks to Spark. So before even getting into more details, a couple of facts about business analytics. Essentially, the department is divided into three major divisions. There are the data warehouse engineers, such as myself. We also have statistics team. And finally, the majority are business analysts. And for the purpose of this talk, we can really separate business analytics into two major abstract groups. There are developers who have MapReduce and Spark skills. And also, we have business analysts who have a variety of skills, but definitely among that, we have SQL skill. So here's our proposition. Spark SQL simplified ETL for us, and it enhanced some of our visualization tools. In addition to that, it allowed any business analyst to quickly build and support new data marts. And finally, Spark SQL enabled a scalable proof of concept to production process for our existing and upcoming projects. So what about the architecture? Well, there are two sides to the equation. There's the developer and the business analyst side. And on the developer side, we do have a Hadoop cluster that we're using to ingest a variety of car shopping-related aggregates, which would include our clickstream data, inventory items, dealer information, and transaction data. And all of those data sets are processed using MapReduce jobs, the result being HDFS aggregates. And interestingly, all of that data is put into S3, Amazon S3, which serves as our main data source for current and historical data sets. Now, on the other hand, business analysts are responsible for reporting, ad hoc, and dashboards. And most of the S3 data is loaded into a database, and for us, that is Amazon Redshift. And finally, at the end, we're turning data into value through business intelligence tools such as Platfora and Tableau. So we can already see there is a clear distinction between the responsibilities of developers and business analysts. So back in 2014, we were already experimenting with a Spark cluster. But in addition to that, we got a Databricks cloud subscription. And we asked ourselves, what can we do with Spark? It's an exciting framework, so how can we make the most of it? And one option was to start replacing MapReduce jobs with Spark jobs. But we realized that there is more potential to be fulfilled doing something differently. And for that purpose, we positioned the Spark cluster on top of all of our S3 data. And the idea there was to set up everything, provide all of the necessary utilities and UDFs, so that we can essentially empower business analysts to leverage all of the S3 data and build aggregates on top of it. And interestingly, up until this point, there was no easy way for business analysts to explore and use S3 data. So we were very excited for the potential of potentially using Spark SQL. So what is step one in that process, exposing all of the S3 data? Well, we had to start creating Spark SQL tables. And for us, we realized the best fit were Spark SQL tables that are similar to their Amazon Redshift equivalent, since both tables would point to delimited data in S3. So we started creating Hive tables, Spark SQL Hive tables using the Hive context, and we did expose hundreds of data sets. However, though, even though we did this, there is a catch. Essentially, even though we can create a Spark SQL table pointing to S3, that isn't sufficient, as all of our S3 data sets are composed of thousands of subdirectories, depending on how often we're putting data into S3. And essentially, whenever you have a new directory with data, you have to register that partition with the Hive metastore. And for that purpose, we did build utilities to make this whole process very easy for business analysts. We built utilities that allows us to pass any Spark SQL created table to one of our methods, so that those utilities can infer its schema, its core location, its structure, and find and register with the Hive metastore all of the partitions that have data, and that would be current and historical partitions. In addition to that, we realized that it makes sense to take full advantage of the in-memory opportunities of Spark. So we also made utilities that can get any Spark SQL table and made a copy of it of a specific period and cache it in memory. And the result there was that, for example, we have a job that makes copy of the last 3 days of our most popular data sets every night and refreshes them in memory, allowing business analysts to do ad hoc efficiently throughout the day. So once we had this done, we really hit a major milestone, because at that point, we had exposed all of our S3 data, and we had the utilities necessary for business analysts to do data exploration on their own. And the next logical step for us was to see how we can use Spark and Spark SQL to enhance some of our visualization tools. And now I would like to tell you a bit about Platfora, which is a visualization analytics tool that we're using at Edmunds, and what we did with Spark to enhance it. So essentially, Platfora is very popular with us. We have more than 200 dashboards. And the way Platfora works involves defining a data set that points to aggregates in HDFS on S3. And the interesting part is that in Platfora, you can build a lens on top of such data set using MapReduce jobs. And finally, obviously, Platfora provides dashboards for product owners to get insights. Now, Platfora is great, but it does have some limitations for us. And essentially, we are using Platfora more specifically for cases when we want to join data. All of our aggregates, such as inventory, dealer information, transaction data, are great on their own, but only when you combine them, you can get very valuable insights that allow you to improve our main product, which is our website. And essentially, whenever Platfora builds a lens on top of a joint data set, it could take a while, as it would spin off hundreds and thousands of mappers and reducers, and this is beyond our control. We cannot optimize it. And in addition to that, the data sets that our business analysts have defined are not available anywhere else outside of Platfora. So now I would like to tell you about a very important data set that is very popular within business analytics and what we did with Spark to improve it. And that is the dealer lead submitter data set. And what is really that? So essentially, whenever we have customers on our website, some of them really want to find the right car for their need and are ready to purchase it. So they would look up our inventory items, and then they would submit an intent to purchase a vehicle that we're giving to our dealer partners. And this is very valuable, but when you join it with other sets, it's even better. And in the dealer leads Platfora dataset case, we're joining with some zip information, further dealer attributes, vehicle information, and even transaction data showing us when was this vehicle sold. And what are the stats here? Well, with the dealer leads Platfora dataset, we have more than 300 attributes, and it usually takes 2 or 3 hours to build the lens on top of it. And for that reason, we can only refresh that dataset only once per day. So the next logical question is, can we improve that performance? And the answer is, of course, maybe we can do it thanks to Spark SQL. And note that at that point, all of the data sets that were involved in that big join were already exposed in as Spark SQL tables. In addition to that, some of the boxes I showed you in the previous slide, they represented joins on their own of multiple data sets. But the key here was to do everything in such a way so that we can empower business analysts. We wanted to make everything simple enough so that any business analyst can support such Spark SQL data marts and create them on their own. And now I would like to go ahead and show you a demo of how easy and cool it is to do this using Spark SQL. And also note that in this case, I'm also going to add some site traffic data. And why would that be useful? Well, the site traffic data set, Spark SQL table, can, when joined with the dealer lead submitter data set, can give us an insight of the customer journey on our website. And that would include entry page, exit page, and other useful statistics. So I'm going to go ahead and show you in a Databricks notebook how simple it is to do all of the necessary joins for that specific data set. So let me zoom in a bit. All right, so this is a Databricks notebook, which I'm pretty sure most of you have already seen if you've been here earlier today. So here's the description of the data sets involved in the join. We have the focus lead submitter Spark SQL table joining with the data sets listed below. And essentially, if a business analyst wants to do on their own, they would simply start crafting a Spark SQL query. And we're starting, as you can see, with our lead data. We're getting all of the lead attributes. And here, I'm doing some lead categorization using some of the lead attributes. And I've really simplified it for the purpose of the demo. But the point is that any business analyst can tweak this until they're satisfied with it. And then, here's the best part. We are grabbing a chunk of lead data. And we are joining with all of the relevant data sets. And that includes region information, dealer information, transaction data, vehicle, and even site traffic. And note that the site traffic Spark SQL table is really big. It has millions of records, as we have millions of visitors every day. And to really optimize that join, we are getting only 3 days of data by limiting the partitions we're interested in, so that essentially the site, the dealer lead focus data set would be only joined with 3 days worth of site traffic data, making the overall join much more efficient and faster. So once a business analyst does this, they can simply wrap this query as a data frame, and this is literally the same string. And then the last part of the data aggregation process is passing that data frame to one of our utilities that can programmatically export that data set to S3. And as you can see, it's a very straightforward process, and anybody can do it. You don't necessarily need some advanced programming skills. So what are the results of this sample data set I demonstrated to you? Well, now using Spark SQL, we can aggregate data in just 10 minutes. In addition to that, we're adding dimensions that simply weren't available before, such as the traffic data. And now Platfora no longer needs to have all of these MapReduce jobs joining aggregates. So now Platfora builds a lens on top of that data set from S3 in just 10 minutes. And really, the overall result is that we have significantly reduced latency. Instead of having that data set refresh once per day, we're refreshing it 2 hours. And our business owners are very happy with that. But what is really the bigger picture with ETL and visualization thanks to Spark? Well, now any business analyst can perform and support ETL on their own. And we have migrated other data marts. And we are currently migrating furthermore data marts that are entirely supported by business analysts. In addition to that, you can see Spark has a very nice spot in our business analytics architecture, as we also provided utilities that allow us to export any of those data marts to Amazon Redshift, for example, for further ad hoc. And finally, we are using Tableau, and usually Tableau would point to our Amazon Redshift tables, but we try to use Redshift purely for ad hoc. So now we can avoid the extra step of putting data into Redshift, and instead we're using a Spark SQL connector that allows us to have our Tableau dashboards point straight to Spark. And now I would like to switch gears and tell you a bit about how Spark enabled us to develop projects much faster in collaboration. And what is the background here? Well, usually whenever we want to create a new data mart, there would be a request to business analysts who would together create something using SQL, maybe pointing to Amazon Redshift. And eventually, product owners would like that data, and they would have more requests, and it wouldn't quite be scalable as it's pointing to our pure ad hoc resource, Amazon Redshift. And the inevitable moment comes when we have to productionalize it and transition it to MapReduce. So I can tell you from personal experience, I've had to convert dozens of lengthy SQL scripts into MapReduce, and it's definitely not a straightforward process. You really need to know all of your requirements in advance, and essentially it involves switching from two very different frameworks, and at the end, you still want to power the same data set, and there is a lot of room for error because you're starting with different inputs. And in addition to that, once we transition a data mart created in SQL by business analysts to MapReduce, it's only supported by developers. And we realized, now that we have Spark, that this whole process could be approached differently. Now, thanks to Spark and Spark SQL, we can have developers and business analysts collaborate together on projects in parallel. And that's still scalable since we're using Spark, and there's no need to switch frameworks once you reach a productionized state of our project. And now, finally, I would like to tell you about a project we achieved thanks to Spark that has to do with the way we're computing revenue, and how essentially it automated revenue computation for us at Edmunds.com. And a couple of definitions are important here. First of all, we are, again, a car shopping website, so we are generating money through advertisement. And a lot of our advertisement comes from car companies. And here, OEM stands for Original Equipment Manufacturer, which is what we're calling those car companies. So a couple of definitions. An impression, it's essentially an ad unit. Whenever you have an ad on a page, you've served an impression. And CPM stands for cost per thousand. So the bottom line here is that if we have served 1,000 impressions, we will generate a certain amount of money determined by the CPM. And more interestingly, a line item is a collection of attributes for a specific ad. So that would include its start, end date, targeting, and CPM, and so on. And finally, an order is a collection of line items. So if BMW, for example, comes out with a new model and they want to advertise it on different pages, they would essentially have an order that contains a bunch of ads on different locations on the website. So having explained all of these, what is the bottom line? Well, we are essentially computing all of our ad revenue after the end of the month using impression data provided from our OEM partners. And this is just the only way you can do it. You can only see how much money you made really finally after the end of the month. And there is a catch here, though, because one would assume that the math should be pretty straightforward. You serve that many impressions, you multiply it by CPM, and this is how much money you made. But in our case, this is not so straightforward, and it just isn't the case, as for each of our OEM partners, for each car company, we have a set of unique rules that determine how the final revenue would be computed. And adjusting those revenue numbers involve the work of an account manager that governs all of these rules. And we have an account manager for every car company. So as you can see, it's not so straightforward. And just to give you some examples of those rules that I'm talking about, we might have on our website a line item called Original that has its own impressions and attributes. And as it's serving ads, there would be another line item also serving ads that we wouldn't be able to connect to the original one, but somewhere out there on a PDF order that was done through the sales team, we know the account manager at the end of the month would go and merge these together to have them go through further billing rules. And more interestingly, line items are adjusted and capped. So it's worth mentioning here that at Edmunds.com, each line item, each ad has a contract. So essentially, we set this in advance before we even serve it, and it's really up to us to serve all of the impressions necessary and maximize revenue. And sometimes we serve more impressions than the contracted amount, and of course, we have to cap that. And the opposite applies too. Sometimes we didn't serve that many impressions, but we served just enough that we exceeded the threshold, and some OEMs would allow us to consider that line item completely fulfilled. So these are some of the most straightforward examples of billing rules, and there are many more. And we asked ourselves, now that we have Spark, can we automate this whole process? And our vision was to have each line item with its own impression data and its own attributes go through a billing rules engine so that after it goes through it, each line item is adjusted to have new impression numbers. And this time, the straightforward math of impressions served by CPM would hold true. That would give us the actual revenue we can invoice for. And there are many challenges in this process, as there are many rules. And when we started this, there was no documentation for these rules. And we didn't even know what we're dealing with to begin with. And they're user-defined inputs. We still depended on inputs from account managers. And also the logic changes. And finally, we also needed a scalable platform. But most importantly, that project involved collaboration between multiple teams, as developers would work on some of the billing rules, business analysts would support a dashboard and pre-aggregate data, and the account managers would give us inputs. And again, how can we develop it? And I'm sure you can guess, given the name of my talk, it involved Spark and Spark SQL. And really, our vision at the end was to have a dashboard that shows us our computed ad revenue after we apply all of the billing rules. And so I would like to talk a bit about the project architecture. And really, the key for us was that we can represent each line item with its own attributes as a Spark SQL table row. And once we do that, we can easily sum and transform rows. And in addition to that, we realized that we can define a Spark SQL table as an interface between multiple phases of processing. And the goal there was to be able to develop the whole project in parallel. And now I'm going to go ahead and show you a graph with a lot of boxes that seems kind of overwhelming, but trust me, I try to simplify it, and I'm going to do my best to walk you through it. So as you can see, there are a couple of phases here. And in each phase, we start with an input, which is a Spark SQL table. And the output, again, is a Spark SQL table. And at the end, we have a dashboard. So in phase one, we have business analysts do the work. And essentially, we start with line item dimension information and impression data from DFP and other sources that we're aggregating. And all of that is exposed as Spark SQL. Then business analysts do all of the necessary filtering and joining. And they end up with our base project input table, the baseline item Spark SQL table. And in phase two, we have business analysts and developers collaborate together. Here, all of the data from the base table goes through a line item merging engine, which is developed purely in Spark. And also note that we're getting manual inputs from account managers, such as all of the groupings that I told you about as part of the rules. And finally, the best part of that whole process is the billing rules engine. And the billing rules engine is essentially a collection of rules that we accumulated from all of the account managers over time. And essentially, each merge line item has to go through that billing rules engine. And note that it's not sufficient just to have them go through the rules individually, because sometimes certain rules apply not just on a line item level, but on an OEM level, car company level, or order level, and so on. So it's really complex. And finally, we have a ad performance Tableau dashboard, which is powered by that adjusted line items table in phase three. So what really is the Spark SQL row in that process, you might ask? And essentially, this project is all about precision and scalability. And every impression and send matters, because at the end of the month, we want to get data that's fully accurate, as this is what we're using to generate money. And as we were adding more car companies through that process, and as we were accumulating more billing rules, we were QAing the data. And Spark SQL, having all of the different phases exposed as Spark SQL tables, made it very easy for us to QA the data and to do aggregations and identify any bugs in the system. And once we would complete a specific OEM and we would verify that the data matches what the account managers would do for previous months, we would add verification queries on top of that data to make sure that we're not introducing any bugs. So they kind of served as integration tests. And all right, so really, before even jumping to the next slide, the best part of this is that ad performance Tableau dashboard tells you how we're doing with revenue with adjusted numbers, not just after the end of the month, but for every single day, for historical periods, for 7-day, month-to-date, quarter-to-date, year-to-date. And it just has so much information that before we couldn't get. So what are really the achievements of the overall achievements of that project, which we did, well, tremendous increase in ad revenue forecasting. We don't just know how we did with adjusted revenue for previous months and years, but we also can see how we're pacing with revenue, which allows our business analysts to adapt and identify any issues with ad serving. In addition to that, we also have cost savings because now the account managers no longer need to either do all of that process after the month or scramble through the middle of the month to give the executive some kind of estimation of how we're really doing with revenue. And finally, we are delivering some information to our ad serving team with adjusted line item information that allows them to detect abnormalities in ad serving. But to me, the key benefit of that whole project was that we had that collaboration between business analysts and developers, and it really set a standard of how to approach similar projects that involve multiple teams collaboration. And we are already using that process on other upcoming projects. And finally, the key takeaway of this is that thanks to Spark, the pre-production version of a project is very similar for us to the productionized version itself. It is no longer the case that we would start a project in a completely not scalable platform, demonstrate that it would work, and then have it completely scratched to start over in MapReduce, which again, it involves its own issues. Now we can do things in Spark and Spark SQL together, and it's very easy to reach to the end goal without wasting too much time. So with that being said, thank you so much for attending this talk. And any questions?
We have time to take 1 or 2 questions.
How much data were you processing, and what was the latency generally?
Are we talking about the billing rules or just generally data?
In general.
Sorry?
In general.
Well, we're dealing with more than 2 terabytes of data per month, so it really depends on the data mart creation. With our dealer information, for example, once we join with data sets such as inventory and traffic, we're dealing with millions and millions of items.
So the latency is right when you run the
Oh, for such large data sets, it would be something it would be a couple of minutes, I would say. Yeah. But we would usually deal with a smaller data set, which I'm hearing from some of the business analysts. They would tackle a very small data set, see that it works, have a notebook that has the whole ETL, and then point to a larger chunk of data.
Can you say a little bit more about the abnormalities in the ad
Sorry,
serving? Can you say a little bit more about the abnormalities in the ad serving, the achievements that you talked about?
I'm sorry, I couldn't hear you.
Can you say a little bit more about the how you detected abnormalities in the
detecting abnormalities? So the question was, can you tell us a bit more about detecting abnormalities? So I talked to our ad serving team, and essentially they're dealing with which ad should be displayed and for how long and so on, and we have to reach a contract. But if you keep some of the billing rules in mind, sometimes a certain ad looks like it delivered plenty of impressions, but it is part of an order that is under delivering. And the ad serving team doesn't know this. And by having all of those adjustments, we are capping and modifying impressions so that the ad serving team would know what is the delivery ratio after billing rules applied. And they take all of these files that we're giving them and they do their own adjustments. Yes, yes, it's not real time, but we are looking to potentially have it done real time.
Hi, here. Do you have any experience with using Parquet files and the performance impact on that?
I'm sorry?
Parquet files, have you any experience with Parquet files?
Not yet, it's really on our agenda. But the nature of our data made it best to start using tables pointing to delimited data because historically we only have delimited data.